Today we're going to talk about how we measure Earth's climate and what we're seeing about what's happening to our climate. To measure the climate, they use two different main methods. First one is with ice cores. They go into the Arctic and the Antarctica and they take out cores of ice, and when the ice freezes in a certain location, it traps with it the atmosphere at the time, so they can measure things like carbon dioxide level and even temperature in that location. And this can get us back hundreds of thousands of years in Earth's history as far as our climate. More recently, what we do is we use NASA's fleet of satellites. As you can see here, we have a pretty good array of satellites that are constantly measuring the energy output from the sun, the energy that the Earth is receiving, and what kinds of gases, as far as carbon dioxide and greenhouse gases, that the Earth is trapping in its atmosphere, and what does that mean as far as global temperatures and global ice levels and things like that. So our second method is satellites. However, satellites have only been useful for about the last 50 years. So they're very accurate as far as their detail, but they don't go back as far as the ice core data. Let's take a look at some of the things that they've found. The first thing that they look for and found is a striking change in carbon dioxide levels across the planet. Over the last 400,000 years, the carbon dioxide level has gone up and down at various intervals, but has never gone above 300 parts per million in the last 500,000 years, up until a significant spike in the last 50 years, where we now are approaching 400 parts per million. Each 100 part per million drop that you see on this scale in Earth's history is associated with a major global ice age. So you wonder what a 100 part per million increase from the highest historical level would be. We can look at more detail with that satellite imagery of just the last 8 years of carbon dioxide concentrations around the globe by sliding as each month passes. You see how the carbon dioxide level has increased by over 20 parts per million globally in just the last 8 years. Well, with more carbon dioxide in the air trapping infrared radiation that's coming off the surface of the planet, you would expect global temperatures to increase over that time. If you look at each yearly global temperature, it goes up and down at intervals, so there is a regular pattern to it. However, if you look at 5-year mean, the trend is upward over the last 130 years. This diagram here on the right helps show that temperature change as well, as you look at temperature difference from the average in that specific location in degrees Celsius. So globally, in the early 1900s and late 1800s, you can see that typically either the average temperature was at the norm or a little below, and as we approach 1950 and beyond, you see much fewer local regions that have below average temperatures, and it becomes much more increasingly likely to have above average temperatures across the globe, no longer balanced. With temperatures going up, you can expect ice to melt. So here's a graph of Arctic sea ice over the last 30 years, and you can see the trend here is downward. You can see that with NASA satellite imagery of the poles. Here is the Arctic as you progress through the years from 1980 forward, and you just see the amount of surface area of sea ice that is disappearing. This would decrease habitat as well as decrease how much reflected sunlight we get, as it is a white surface and very reflective. So with fewer ice sheets, you would get more solar radiation being absorbed by the Earth. Land ice, like in Greenland and Antarctica, are showing the same trend, downward. as global temperatures increase. You can see the amount of ice mass change in just the last 5 years. Significant amounts. Land ice, as it's not in water yet, when it melts would increase sea levels. So we're also seeing a significant increase in sea levels globally. And you can see in this graphic as well how the sea level has changed around the oceans in millimeters as you progress forward from 1994 through 2008. So we definitely are seeing the effects of certain changes around the globe as far as climate, and we are recording those with ice core data and satellite imagery, and hoping to get enough awareness of these climate changes to do something about it before it becomes a runaway greenhouse effect. Thanks.